Thank you for coming out tonight. This was a wonderful presentation at the AYC, and I'm delighted that Bud is free to do it again. You all know Bud, but I'm supposed to say that in addition to heading the Union of Concerned Scientists for many years, and then the New England Aquarium for many years, and then as a consultant to the Barr Foundation, and now with the Boston Green Ribbon and Boston Harbor Now, Bud knows climate change, and particularly knows what it means if you live near the water, which we all do. So I think there you go.
Good. I don't need that.
Oh, you don't need that.
And somehow I got into running farmers markets also, but many of you probably see me there. I hope everybody will come this Friday. We're having a great time doing it, and we have a couple of pop-up events or vendors every Friday, so it's always something new. So anyway, delighted to be here. I started with that slide because that's where I was at the talk a week or two ago, but we're going to broaden it a little bit to talk more about the village as a whole. My background, Paul sort of briefly summarized, but I've been working on climate change since about the mid-1980s. So do the math, that's 35 years or so. And at that point in time, I was running the Union of Concerned Scientists down in Cambridge. And we did a lot of the early work on trying to understand the impacts of climate change on various parts of the United States. We did a lot of work on alternative energy and fuel economy and automobiles as the solution strategy. And back at that point in time, most of what we did was a big debate about the science of climate change, because there was a lot of debate about it. There were a lot of naysayers who said this was not a problem. And so I spent 20 years of my life sort of trying to demonstrate what the scientific community knew and what the consensus was. I'm happy to say today, I think we're past that stage, and we're arguing about what to do about it and who needs to do something about it, rather than is it a problem. But in the meantime, while we spent 30 or 40 years arguing over it, a lot of carbon was emitted into the atmosphere, and now we're starting to see the effects of climate change. So I spent the first 30 years of my life trying to figure out how to prevent the problem through what we call mitigation, and I'll get into that just in a minute. And the last sort of 10 years of my life since I was at the aquarium focused more on how to deal with the problem of sea level rise, particularly in Boston, and partly because the aquarium was sort of the epicenter of the flood zone right in downtown Boston. I became, through my role in the aquarium, a member of an organization called the Boston Green Ribbon Commission, which was started 10 years ago by the mayor of Boston, Tom Menino, and Amos Hofstetter, who was the head of the Barr Foundation in Boston, to bring the private sector and the academic sector and the healthcare sector together to work as partners with the city of Boston, both on reducing the emissions that cause climate change and trying to figure out how to minimize and address the impacts of climate that face Boston. And I helped design a project which became known as the Climate Ready Boston Project, which is now in its 7th or 8th year. The basic focus of that program is how can we prevent Boston from having to move to Worcester as the water rises. It also deals with heat, which has been even more of a big focus now in the last several months, and so on. So I've had done a lot of work in Boston running that program for the Green Ribbon Commission over the last 6 years. And it's all about sea level rise and all about flooding. And so hopefully I've learned to talk about it in a way that's fairly straightforward and fairly simple. I'm going to warn you, there are lots of numbers, but I always try to have a slide that summarizes everything. There are 3 charts in the middle, if you make it that far, one of which is really easy to understand, one of which gets a little harder, and one is really hard. But I promise you I'll have a summary slide after that, all right? So climate change 101, first off, there's a blanket of gases that surround the globe about 100 kilometers out. When we have just the right constituents in that blanket, it keeps the Earth at a nice temperature that makes life good for all of us, and that temperature used to be 57 degrees. But when we burn fossil fuels like oil, coal, or gas, it emits carbon, which combines with oxygen in the atmosphere, and it increases the amount of carbon dioxide in that blanket, which keeps more heat in. That's the basic phenomenon of climate change. And what we now know is there's a very clear correlation between the amount of carbon dioxide in the atmosphere and the temperature of the Earth. So the blanket is thickening over time. And this shows you, over the last this is just the last 40 years or so, when we've gone from 280 parts per million of carbon dioxide in the atmosphere to now more than 400, which is a number I didn't think I would see, that we'd get that bad, when I started working on this 30 or 40 years ago. But there's a very clear correlation in temperature. And the really challenging part of this problem is once you put a molecule of carbon dioxide in the atmosphere, it stays up there for 100 years. So it's not a problem that's easily reversed, which is what makes action now really, really urgent and imminent. The US is warming about 2.4 degrees, so that doesn't sound like much, but that's what's just happened since 1970. Air conditioning always makes me a little foggy in my throat, sorry. And averages don't tell the whole story. It's the extremes that are really important. And anybody who's been looking at the news or newspapers in the last few weeks, Portland, Oregon, the rainy, wet place we all think of, 130 degrees, Phoenix, 118, et cetera. And then even here in Annisquam, those of you who are gardeners know that we've changed one zone of our climate, so we have to plant a different kind of plants. And the first frost in the fall is now about 10 days later than it used to be. And the last frost in the spring is now about 10 days earlier. So, we see that right here. Sorry about my voice. Boston this year, we've already had 8 or 9, maybe even 10 days now after today, over 90. The average over the last several decades is about 11 per summer. We're going to probably do much more than that as we go forward. So it's here. This is one of those little harder slides, but there's some uncertainty in the science that I'm going to talk about, but the biggest uncertainty in trying to project the future about this problem is we don't know what the world is ultimately going to do about it. So there's always scenarios like the blue line, which is if the world does nothing about the climate problem or does very little, we get on a trajectory where we put a lot of carbon dioxide in the atmosphere and we got a lot more global warming. If the world takes action, takes really serious action, we get the green line at the bottom. There's a lot less warming and the projections all have a lower boundary that's much more pleasant to live with than what happens with the worst case. So when you see some of these presentations and people talk about, well, we might have 30 days over 90 degrees by 2070, or we might have 100 days over 90 degrees, it's because we don't know what the world is going to really do to try to reverse the problem, or at least slow it down. Make sense? Yes. So I'm going to get directly into sea level rise. There are 4 main causes, and I'll go into each of these except the 4th one. Thermal expansion of the oceans, melting of glacial ice sheets, melting of continental ice sheets, and then what we call regional or local subsidence. Boston's a good example. Most of the waterfront in Boston was built on fill, and it consolidates over time and it sinks over time. So you get the water rising and the piers sinking, which increases the effect. Here in Lobster Cove, if you look at the pier in front of my house on 44 River Road, it's probably compacted and subsided, as probably most of the piers have around here. So that's probably one of the reasons why it floods more. But it's probably a minor part of the problem compared to what we're now seeing from these other causes. The oceans absorb 90% of that extra heat that's created by climate change from that blanket of gases. So that's where a lot of the heat ends up. And the oceans cover 70% of the Earth's surface, which is a lot of water. And if you can remember from 8th grade chemistry, what happens if you heat water? It expands. So if you heat 70% of the Earth's surface, where's that water going to go? It's going to rise. So up till now, this has been the greatest contributor to the rising seas. And I'll come back to that in a second. Thermal expansion. There's no quiz at the end of this, so you relax. You probably read and have seen photos from all over the world of glaciers melting. This is from Glacier National Park. That used to be, that whole side of that mountain used to be solid ice. It's happening in the Himalayas, it's happening in Europe and almost everywhere. When that water melts, where does it go? It goes down all those rivers and ends up in the oceans. And up until recently, this has been about 10% of the sea level rise problem. The third contributor are the ice sheets on Greenland and Antarctica, both of which are ice on top of land or stone. And they are very big places. So the white area on the left is, I'm sorry, the yellow area on the left is Greenland, and the white area on the right side is the South Pole, or what we know as Antarctica. Those are very, very large continents with a lot of ice on top of them. If all of the ice in Greenland were to melt, we'd see about 21 feet of sea level rise globally. And if Antarctica were to melt, we'd see about 160 to 180 feet of sea level rise. Hopefully that will not happen. But what we now know is in both places that ice is melting and it's accelerating. 5 years ago we were less certain about that, but it's much clearer now. You're probably wondering, what about the Arctic up north, where you've read a lot about the shrinking size of the ice mass? Well, that ice mass floats in the Arctic. There's no land under it. So if you put ice in a cocktail, next time you go to the yacht club or wherever and have a gin and tonic, draw a little line around that glass where the level of the drink is, or do this at home with water, and put ice cubes in it. As the ice melts, the water level doesn't change, because the mass of the ice has already displaced the volume of the water underneath it. So when the ice in the Arctic up north melts, it doesn't contribute to sea level rise because it's already in the water, but it exacerbates the problem because we change from a white mirroring surface to dark water, which then absorbs more heat and contributes to thermal expansion. Still with me? Yes. This is the simple part. Good. Yes. All right. All right, so what's happened over time? This is the trend in Boston. Boston has, I think, the oldest tide gauge in North America. We were always first in everything. We had the first tide gauge. And the sea level clearly has risen in Boston about an inch per decade over the last 90 to 100 years. Some of that is caused by land subsidence that I mentioned earlier, as the waterfront has compacted a bit, but I believe the tide gauge is on solid bedrock, so it probably doesn't show too much of that. This is the more important slide. The last slide I showed you sort of averages everything over 100 years. If you can see on this chart, the green and the yellow dotted lines to the right, which got averaged in on my earlier graph, you can see that the rate of sea level rise is now clearly increasing. From 1991 to 2009, we went to 4.3 millimeters per year. 2001 to 2019, we went to 5.4 millimeters per year. What that really means is we went from that 1 inch per decade on the earlier slide now to 2 inches per decade. Doesn't sound like much. 2 inches per decade times 10 decades is 20 inches in a century. We're headed towards 3 inches a decade times 10 decades is 3 feet in a century. Some of that is already locked into the system because there's so much heat now already embodied in the oceans, and so much of that melting is already going forward. So that's the bad news. And then for a lot of very complicated reasons, we expect Boston metro region, including Gloucester, to have more sea level rise than the global average. This is really complicated, what I'm about to say, but it's really interesting. So not only does Antarctica and Greenland contribute to sea level rise because the ice melts and slips off into the oceans, those land masses are so big that they actually have their own gravitational force that attracts the water around them toward those continents. And as they get smaller, because the ice falls off, the water is less attracted to them and goes elsewhere. And you would think Greenland is our biggest problem. Actually, Antarctica is our biggest problem because all that water will come north. I can certainly see it, I see it once a month. This is the view from my porch, basically, at 44 River Road right over here. That's the old pier. Does anybody know when that was built? I've never been able to find it.
It's in the waterways records. It's all pre-colonial.
Pre-colonial.
Yeah.
So it's all, yeah. So
the documents are available.
yeah. So what you see on the left is kind of what I see every month. And then, in Annisquam here, the tides, how many people are boaters or sailors? Probably a lot, right? So you all know you know, the average tides are, tidal exchange every day is 7 or 8, 9 feet, and then it goes sometimes to 10, 11 feet when we have a full moon, right? So on the left is kind of the average, you know, the monthly high tide, and then when we get magnified by the condition of the moon and sometimes the sun, we get these really big tides, and that pier is now a foot underwater in those big tides. So these are the 3 slides that get increasingly complicated. These are the latest projections for our area. This was done by the Boston Research Advisory Group, which is a group the Green Ribbon Commission put together, composed of about 30 scientists, all leading climate experts and oceanographers from the leading institutions in the Boston academic community. We're lucky to have that kind of community here. And they looked at those different scenarios. That first slide I showed of the blue worst case and the green best case, and said, okay, we pick each of those scenarios and let's lay out how much melting we will get, how much thermal expansion we will get, and what will that look like going forward. And to simplify it, by 2050, 7 inches to 1.5 feet. This is relative to where it was in the year 2000. So you remember I said we'd done 2 inches a decade, going to 3 inches a decade. So then it just sort of computes out. By 2070, it starts to escalate, maybe as much as 3 feet. And then by 2100, somewhere between 2.5 to 7.5 feet. And the basic difference there is whether the world does something about this problem and reduces those emissions of carbon that cause everything. Then the Commonwealth of Massachusetts did their own analysis in 2018, actually using a lot of the same scientific expertise. And they selected a worst case scenario because they're focused on assets that have a long lifetime: roads, bridges, sewage treatment plants, water treatment plants, land that's owned by DCR, et cetera. So you're talking years, 70, 80, 90, 100 years or more. So they tended to go towards the worst case selection. And these are the numbers they're now using for their design criteria in their projects across the state. 2050, 1.5 feet to 2.5 feet, and then 2100, 4 feet to 7.5 feet. And this is the mother of all charts, okay? We'll give it a quick stab. So the Boston Research Advisory Group has now become the Greater Boston Research Advisory Group, and they are updating the projections they did in 2016. And this is a new set that's going to be coming out in this fall in September. And don't try to understand this too carefully because it's really hard to read. On the left side are those 3 different emission scenarios: 2.6, 4.5, and 8.5. Then the years on the left. Then across the top are the probabilities of what level of sea level rise will occur during those time periods, given those emissions ranges, right? And in the middle is, you see the 0.83. That means everything below that has an 83% chance or better of happening. And then as you go to the right, there's lesser chance. So that middle yellow says what has a better than 83% chance of happening, but less than a 17% chance that it will be worse than what we show here. And that's how this chart, and they did that through 10,000 random runs of a computer with all that data, in much more complicated than what I talked about, plugged into it. But the numbers are consistent again. By 2050, 10 to 20 inches compared to what it was in the year 2000. By 2100, 2 to 5 feet. And then maybe less than that if the world takes at least some action. We get a much better sort of outcome. But this is what they're now using in Boston to make all their design decisions. So just in summary, the rate of sea level rise in Boston is accelerating. It was 2 inches a decade. We're moving towards 3. 5 to 6 is possible, unfortunately, by the end of this century. And do the math. If we're 5 inches a decade times 10, 50 inches over a century. Everybody seems to agree that the near to midterm projections are 10 to 20 inches. And that's kind of already baked into the system because there's so much inertia in the natural system. Almost no matter what we do, at this point, we're going to see something in that range. You can't ignore the worst case. Boston has selected 40 inches as their design guideline, and they're creating a new flood zone in Boston that assumes 40 inches of sea level rise. As I mentioned earlier, the most uncertainty is due to the shape of global emissions. It's really important. Something we've really learned in COVID, science is really important. And so you've constantly got to monitor updates in the science itself. Actual sea level rise data, go down to that tide gauge and see what's happening. And there is a NOAA project here now, actually. They're using a benchmark at the bridge to see what's happening in Lobster Cove. And then, of course, you've got to lay out the future. How are we doing, all right? I'm 2/3 through. So what does this mean for our area? You know, and a lot of people use maps, and a lot of people are always looking at the water when it's highest, like I showed you earlier. And, you know, that's the sort of scariest scenario. I think I've been working on this too long myself, because what I always look at is the average high tide line around town. I think it's much easier to see at low tide. So you can see the dark, where the stone is darkest on the right, or in the back on the other side of Lobster Cove on those piers. You know, so that's that average high tide that's 7 or 8 or maybe 8.5 feet every day. And then we get the really big tides that are 9 or 10 feet once a month, and sometimes 11 feet during the year. So if you look at that dark line and realize that that's actually the average high tide, and we already get another couple feet on top of that, you can see in many places around Annisquam, we've only got about this much less till the water's running up on the grass, right? Now, fortunately, most of the houses are much higher than that. I'm going to try not to single anybody's house out here, because I don't want to get in trouble. Cambridge Beach, you know, has an additional problem. Not only do they have to worry about sea level rise, but during storms, they have to worry about wave energy. We don't have that problem, or I don't have that problem here in Lobster Cove, but they may get waves 5, 10, 15, or even 18 or 20 feet or more. So you know, houses have to be a little higher up over there. David Lehman has a little problem, and he knows it. We've already talked about it, but he's trying to figure out what to do with his beloved place on Cambridge Beach. And then the yacht club, and I'll show you another slide of that. And then on the right is what's actually known, I've discovered, as Stage Cove. I used to call it Bent's Cove, and everybody else calls it Dirt's Cove. But and Tom and Karen, you'll know that area really well. But there's your dark line, and you can begin to think about, without looking at any maps, at 3 inches a decade, or if you're going to leave it to your great-grandchildren at 4 or 5 inches a decade, you know what that might look like. Is that helpful?
Yes.
Yeah. But these are the slides that most people show. This is the yacht club last December. The boat is actually the yacht club launch, and it's on a trailer. It's not in the water. There's about 1.5 feet of water in the yard over there on that day. And then on the right, as you can see, we've got about this much room till the water's coming through the holes in the knotty pine floor in the yacht club. So the yacht club is probably one of the most vulnerable buildings in all of Annisquam. I think the Remsons elevated their house. Anybody know? Maybe about this much which was a smart thing to do. Our biggest threat is really here more from nor'easters than from hurricanes. You know, we have the advantage of being above the big elbow of Cape Cod, which protects, you know, Boston and the Boston metro area from a lot of hurricane tracks. But we get nor'easters. And the problem with a nor'easter is it can last for several days. So you can go through several tidal cycles, and you're more apt to have things happen at a high tide. Boston was very lucky. When Sandy hit New York, it came to Boston at low tide and saved us a lot of damage, but it hit New York at high tide. Well, the nor'easters are very different because it can last for 48 hours, sometimes even longer, as you all know. Unfortunately, we don't know much yet about what's going to happen to nor'easters. Are they going to get more ferocious in the future? Are they going to get more frequent or not? We're beginning to understand hurricanes, which have been studied much more extensively, and it's getting to be pretty clear that hurricanes are getting more intense. But it's also believed that we might have less of them in the future. So there's some uncertainty about that. And we really don't know a whole lot about nor'easters yet. But even if the current regime that we have in terms of the frequency and intensity of nor'easters doesn't change, and we have more water because of sea level rise over time. What is a 1 in 10 year winter storm now will likely become an annual event by mid-century, and the 1 in 100 year storm will likely become an annual event by the end of the century. And these numbers are always confusing. 1 in 100 doesn't really mean if the storm comes 1 year, it won't come from another 99 years. We wished it meant that. What it means is in any given year, there's a 1% chance of that storm occurring. So we go from a 1% chance of it occurring to a 100% chance of it occurring by the end of the century. I'm actually going to end on a hopeful note. So, there's now a lot of good mapping tools here in Annisquam that everybody can use. You're probably all, excuse me, if you have land along the waterfront, you're certainly familiar with FEMA maps. This shows the 1% flood, and virtually everything below River Road along Lobster Cove would be flooded quite seriously in that kind of storm. But you always have to keep in mind in looking at these FEMA maps, they're based on past history. They're not based on the future. So they're based on storms of record. And the big one, I think, is 1978 for this region here. The reason for that is that if people had to go to court and litigate over whether they should get flood insurance or not, the belief was it's much easier to tell the judge that you can pull out these photographs from history showing what actually happened versus bringing Bud and a bunch of scientists in and saying this is what might happen in the future. So unfortunately, FEMA has always looked backward, not forward. They're looking at reforming that now as their science has gotten better about projecting the future. Got it? And Val, you may want to comment on any of this, but the city of Gloucester did its own vulnerability assessment about 3 or 4 years ago, and they focused on trying to find all the low-lying areas that were basically publicly owned. So roads, sewer treatment plants, pump stations, all those kinds of things. The red lines and the red circles show you those areas. You can clearly see River Road, which is that sort of U-shaped thing at the top of the chart above the 1, which is what we saw on the other maps as well. Ever think about 128? I know we've come here for 40 years, and when the kids were in the car, we'd always, just before we get out the bridge, we'd look out to the right and say, kids, is it low tide or high tide? That section of 128, it's got about this much margin. That's important not only because we don't want to drive through it when it's wet, but if we have a really big nor'easter 30 years from now and it lasts for 3 days and we have to get out of Cape Ann, how do we do that? So, and then Val, where is the sewage treatment plant on there? It's number 7 or 5? Yeah, so that's a very low-lying area, and I think the city has applied for or received a $3 million grant to protect the treatment plant.
That is correct.
Is that correct? Yep.
And for the Q&A, I got notes from Greg Catavatore to bring here that I can summarize.
Bring us up to date. Great.
What we're doing.
Good.
So,
Perfect. And then there's a new set of maps coming out. This one's, they're not yet available, and they're a huge file, so when I tried to scale it just to look at Lobster Cove, it didn't work very well. But they're going to show 2 things in 2030, 2050, and 2070. They're going to show what is the probability of flooding, and they're also going to show the depth of the water. And that will tremendously increase the mapping capability we have compared to what FEMA has used for years. And that will be publicly available to everybody. I think the most interesting thing that you can see, just even the scale of this map, is look what happened to all of the wetlands that we go in our Sturdy Cats and other boats along the Annisquam River and the Jones River. At some point in time, they may become permanently submerged. And the real tragedy of that is wetland grasses cannot survive if they are submerged on an all too frequent basis. So there's a big ecological question of what's going to happen to the Annisquam River and the Jones River, and then the Great Marsh behind Plum Island and all those areas that we really cherish. Same is true in Boston. The Belle Isle Marsh and the Neponset Marsh on both ends of the city are the last remaining wilderness areas in Boston proper, and they are threatened by this as well. So, I think these are the kinds of questions that you have to consider. If you need to do something, what's your planning and design frame? Are we designing for the next couple of decades, or do we want to think longer term? And that obviously depends on what the building or the structure or the infrastructure is, what's the lifespan of it. You got to pick a target. At some point, you got to pick a number. What are we going to accept as our level of risk, and what are we going to build to? What's the storm surge potential? This is another complicated subject, but low pressures associated with storms also makes the water rise, and that comes on top of sea level rise. On the outer parts of, of our land here, we have to worry about wave energy. There's tidal fluctuations. Every 18 years, we go through a different tidal cycle, and the tides are a little higher, and then a little lower, and then a little higher again. It's a smaller factor, but it is a factor. And then ultimately, how much margin of safety do you want, what we call freeboard? You know, how much comfort do you want to give you? How many gin and tonics worth of, comfort do you want to get while you're sitting out there? What are other cities and towns doing? As I mentioned, Boston has selected 40 inches as its benchmark between here and 2070. I think Gloucester has picked a similar number. Maybe it's 3.5 feet, which is very similar that they're using. You can think about maybe we have some near-term needs. So the next time we're going to replace our furnace, rather than putting it in the basement, maybe put it upstairs. If you live in a vulnerable area. If you have an electrical panel in your basement that needs to be upgraded, think about putting that higher up in a safer zone. I think the Yacht Club, one of its near-term order of business is the pump station. That's that little wooden structure just as you go out the gangway on the left. It was surrounded by water in that flood last year. If you own docks or things floating in the water, maybe the tie-down system has to be strengthened as the water rises and they become more vulnerable. And then, as I mentioned, there are all kinds of public infrastructure. At some point, River Road is going to have to be raised. Probably the road 127 where Plum Cove is will also have to be raised. Have you noticed that new set of condo units, I think, that were built there that are quite high? Somebody had some good foresight. And then longer term, and this is a big question that we talked a lot about at the Yacht Club, do you pick a number that's 20 years from now and elevate it a bit, knowing that you'll have to do more in the future? Or do you go for the big number now and get it done all at once? Do you elevate or rebuild? Do you consider floating structures? And I've got some photos that I'll show you. And then there's this great euphemism, should we think about managed retreat, which means rather than waiting till the storm comes and everything gets damaged, maybe there's some places in this town where people actually should move away from the water. We all love our views. We all love the beach. Who wants to move? It's a big question. But you're seeing this big time in places like Miami, Myrtle Beach, where they've been inundated over and over again, and the public taxpayers are paying for rebuilding their road 7 times. Then it becomes a really easier question, I think, to answer. The city of Boston, and you can look it up and Google it, has done a great set of guidelines. Believe it or not, there are single-family homes in Boston, and so a lot of this is relevant to here. But they came up with a set of design guidelines for all kinds of buildings, from these to 50-story skyscrapers in the city, and it's about a 100-page book with lots of great drawings like this that is really useful. And what they're showing here on the right, you can see the hot water heater got moved to the 2nd floor. They elevated the whole building, and then they created something in the lower level that is kind of expendable. So you might keep boats down there or things that could get wet, that you wouldn't worry about it so much. But all the occupancy is up higher. Ultimately, you got to think about what's going to keep things safe, both the buildings and the people that live or work in them. Functionality, this is a big issue here, and it's an interesting question with a yacht club or if you own houses on the water. If you elevate it, 5, 6, 8 feet, then you got more steps to go down to today's sea level, right? And that's a big problem when you see Myrtle Beach and Miami and other places where they elevate these houses 14, 18 feet. That's a lot of steps to get down to the bottom. Not very good. There's aesthetic questions. Obviously, cost is a big one. Insurance is a big one. Maintenance, what do you have to do to take care of it, et cetera. There's a lot to learn from other places. My nephew happens to be a member of the Bayhead Yacht Club in New Jersey that was massively flooded by Sandy in 2012. I could show you lots of expensive-looking drawings about how they lifted the whole yacht club. They put it on rails, rolled it back 100 yards, put new pilings in and then brought it back and elevated, but this is the finished product. They added that lower floor, which is all for boat storage. And it's now quite nicely protected. In Boston, just 2 months ago, we had our first proposal for an entire floating housing development. So this is in Charlestown, and this is the kind of thing they do in Amsterdam and Copenhagen and other places in Europe. The pilings have collars on them that the docks and the houses are fastened to, and they just go up and down. I think for the yacht club, this is worth looking at. It's a way of not having to get you up so high so that it's such a long way down to the water. How you keep it stationary and how you can eat oysters and have a beer without getting seasick is the problem. But obviously they can do it for homes, and they all eat and sleep in these places. And we, of course, have our great experience with lots of floating structures here. There's Dirt Sauna. And you've seen lots of floating houses. I'm not saying that's what we should do, but obviously people have done it, here in Annisquam. And I had a great validation from Dirt. He said, I heard about your talk. I couldn't make it, but I can just tell you that where I keep my tools and I store various things over on Goose Cove, every 5 years I've had to move them to higher ground. So he sees it. And then my own validation, this is where I keep my sailboat on Long Wharf in Boston. And for the life of me, I can't figure out, my sailboat is moored right here to the left, and I can't figure out where my boat was when I took this picture. But, so my marina is the oldest operating marina in Boston. It goes back 4 generations. And if you can see this big piling in the center, and there's another one behind it, that's the pilings that had been used up until 3 years ago. And now that marina has added 5 feet on every piling in their marina. And if you can just barely see the welding line right in the middle of that piling. So that's another sort of testament. That's been through 4 generations, this marina, and they see what's happening. In the big storms in 2018, those 2 winter storms where we had floods in Boston, the collars of the docks actually came over the top of the pilings and almost broke free. So the hope, we don't have to get on that worst case trajectory. We've still got time to get off of that trajectory. The US is back in the game internationally, which is a good thing. And we often forget we've actually decreased our emissions 21% already from their peak about 30 years ago, which is a good thing. I can remember a time when electricity produced by coal was 52% of our electric grid in the United States. It's below 30 now. So we've made some progress. The EU, you may have read in the paper last week, has set now some really aggressive targets for cutting carbon, trying to bend those curves down. They want to ban all gas and diesel vehicles by 2035, which is now only 14 years away in all of Europe. China has just launched a carbon trading program that they're using from province to province to bring down their emissions. They've got a long way to go. For the first time, the United States, the Commonwealth of Massachusetts, and the city of Boston and other cities have all said we're going to get to 0 carbon by 2050. So there's harmony in the public policies, which is good. Annisquam has its own little initiative underway, started by the church. We actually, I think, now have 15 homes that are solarized just here in Annisquam out of maybe 100, maybe 120, something like that. If you walk around town, as I do several times a day, you're going to see plugs now all over the place. Lots of people have electric vehicles. We have a stretch on River Road where we have 4 in a row, which is really great. So that's my house. We added solar just 2 months ago. The first bid I got 4 years ago was 20 to 21,000. We just paid 13,000. So the price has come down, and the economies of scale have really improved. To some degree, there are no major technological barriers. We're just basically talking about economies of scale and politics to get it done. I'm exaggerating that a little bit, but I can remember a time 20 years ago, we were arguing about whether a windmill would ever work. And as I said earlier, now we're arguing about where to put it out in the ocean and how many put out there, right? So it's changed. Renewables, including hydroelectric dams, now account for 20% of the power in the United States, of electric power. So we've made a lot of change, and we can do a lot better. There's hope. Thank you.